Welcome back, and now we're going to graph tangent in a different way other than transformations. Remember, we have a 5-point method that we discussed with sine and cosine at least, and the question is, can that be adapted for tangent? You bet. So the way we're going to adapt it is pretty much follow the same steps. The only thing that's going to change really, and I have it or I have it in red text right now, is that when we look at that bx minus c, that middle chunk that we put into tangent, we're going to sandwich it between negative pi over 2 and pi over 2, okay? And this is done because before we did it from 0 to 2 pi, remember? So the period for tangent is normally pi, so this interval has width pi. And so you could certainly do this from 0 to pi. The only bad thing is that there's normally an asymptote at pi over 2, so you're going to get like a break in the middle of the graph and it'll look kind of weird. So that's the only reason why we do this particular interval, because now we will have asymptotes, those vertical asymptotes at the left and right boundaries. So that way we just don't have any breaks in the middle. But nevertheless, we have this procedure that we're going to pretty much follow the same way. So set the inequality up, solve for x, divide it into, or determine the interval width, that period, divide it into 4 pieces, and then increment from the starting value that we'd have in the left of our inequality up to the right endpoint of our interval, going or increasing by the interval width we got from number 2, and then we set a table of values. This step is also a little new. Because we're working a tangent which has a different parent graph, we have to initiate values differently. So we're going to do undefined and then -1, 0, 1, and undefined again. Undefined is representing those vertical asymptotes. Okay, and then add a column, multiply by A, add a column, add D, and we're good to go. Okay, so let's see this thing in action. Okay, so here's my function. I'm going to start by taking the input, that part that's inside of tangent 2x minus pi over 3, and sandwiching it between negative pi over 2 and pi over 2. Okay, and all I'm going to do here is solve for x. Okay, now the arithmetic, yep, it could be a little bit of a pain. I get it. It might be easier if you think in degrees, but so this would be 90 degrees, and then we're adding 60 degrees to all the parts. So we add pi over 3, and so then, let's see, that would be 5 pi over 6, and then this would give me pi, negative pi over 6. Okay, so still, the interval width is still pi, and now I need to divide by 2. And so then my inequality when I have it solved for x is going to be from 5 pi over 12 to negative pi over 12. We have our inequality solved, so then the next thing is to determine the interval width. So again, you would take the right endpoint minus the left endpoint, and that would give you the period. So the period here, if you do that arithmetic, you get pi over 2. Okay, and then again, if you want, this would be the left endpoint would be your phase shift. So I got phase shift, period. Amplitude, not applicable here. That was just a test. And vertical shift would just be the -1. Okay, so we have all the different pieces, but we're still not ready to graph. Okay, next step, so I've done kind of steps 1 and 2 from above, right? Or sorry, step 1, and I need to now do number 2 is to divide the interval width, aka the period, into 4 pieces. So I get my increments, and that's going to be pi over 2 all over 4. Mathematically, you get pi over 8 at the end of that. Okay. So then, now I'm ready to make a table of values, as in number 3, increment from the horizontal starting place. Okay, so I'm going to make an x table. I'm going to start at negative pi over 12 and increment by pi over 8. This is going to be fun to add, let me tell you. So I'm going to pause the video, write them down, and then resume the video once I have them all set up. And so here are the x values that you end up using. I actually had to like whip out a calculator and do this myself because yeah, fractions are fun, but sometimes you need a little bit of help. So I have the x values here. Again, to get from one to another, I just, let's undo that. To get from one to another, you just have to add pi over 8, okay, to each one. All right, nevertheless, I have a start to my table. The y values, now this is different than sine and cosine because our graph is different than sine and cosine. As I stated above in the steps here, you're going to start the first value with undefined because it would be a vertical asymptote. So we're just going to do undefined, and then it would be -1, 0, 1, and undefined. Okay. So these are the y values we initiate things to, and then we follow the same procedure of taking a times y. So, I mean, you multiply something by undefined and you still get something that's undefined. And a here is 4, so then I just have to take 1 times -4 is, -1 times 4 is -4, 0, and then 4, and then undefined. And then lastly, I have to take this ay value that I found and then add d to it. D is -1, so undefined, -5, 0, -1, 3, and then undefined. Okay, so let's see this on our graph. All right, so vertically I'm going to be fine. I don't have to do much work. The horizontal work is going to be kind of interesting. So what I'm going to do is I'm going to say that this is this right here. Maybe I'll do it. No, I'll do it in blue. I'll do it in black. Just kidding. Minus pi over 12. Okay. And then for spacing, I'm going to say that this is, well, let's see. Let's do pi over 12 here. And then I'm going to say every 2 spaces is going to be a pi over 8. So the scale here is going to be a little wonky, but we can work with it. Actually, I'll do every 3, just spread it out. So pi over 24, and then 1, 2, 3. This will be pi over 6, 3 more. This will be 7 pi over 24. 1, 2, oh, and I need a third one over here. That's fine. This will be the 5 pi over 12. Okay. So now to graph these, right, I'm just going to plot the points. So I have negative pi over 12, I have undefined. So I'm just going to put a vertical asymptote here. Something like this. Okay, so there's my vertical asymptote. Pi over 4, -5, or pi over 24, -5. So 1, 2, 3, 4, 5 right there. Pi over 6, -1. 7 pi over 24, comma 3. 1, 2, 3. And then out here I'd have another vertical asymptote. Okay, now technically when you were to check this on, say, Desmos isn't going to draw the vertical asymptote, but you sure can. And then tangent is going to have this general shape of rising as you go to the right. Okay, again, arrows on each end, and we're good to go. Okay, so we've done the 5-point method with tangent. Again, the big differences are that at the beginning we sandwich it between negative pi over 2 and pi over 2 just so we see one complete period with no breaks. Solve it, and then really all the other steps are similar up until you're ready to initialize, right? So initialize according to this general pattern of undefined, -1, 0, 1, undefined, and you'll be good to go.